Okay, we're going to talk about simplifying square roots. The first thing we're going to look at is just simplifying square roots with just numbers or just constants. So here I've made a list of very nice, pretty numbers. We call them perfect squares that you can take the square root of. When we're simplifying a square root, if you try to take the square root of 18, you won't be able to find a nice, pretty number. When we plug a square root of 18 in our calculator, it's going to be 4 point something. It's going to be that 4.24264. So what we're going to do, we're going to simplify square root. If you don't know what the square root is, we're going to simplify it. So what we're going to do is we're going to break 18 down into two square roots that multiply together gives us 18. So some factors of 18 are 1 times 18, 2 times 9, 3 times 6. Now when you're picking your factors, you want to pick factors that have either one of the factors or both of the factors are perfect squares. So I see 3 and 6, I can't take the square root of 6 and get a pretty number. I can't take the square root of 3 and get a pretty number, so I don't want to use those. I'm going to pick 2 and 9 because I know the square root of 9 is 3. The square root of 2 is an irrational number. It's a not pretty number, so but that's okay. We know what the square root of 9 is. The square root of 9 is 3. The square root of 2 is messy. That's what I'm going to say. It's a decimal that goes on forever without repeating. It's irrational. Since we don't know what the square root of 2 is, we're going to just keep our answer 3 square roots of 2. And that's our answer. When you simplify square roots with numbers, you should be able to check your answer. Simplifying doesn't change the value of it. It just, it's like that was cursive and that was print. We made it maybe a little bit simpler, hopefully. So the square root of 18 is 4.2464. When I plug in this 3 square roots of 2, which is what we got our simplified answer, we should get the exact same decimal. Okay, that's a way to check your answer. So let's try this one, the square root of 32. You can break 32 up into 4 times 8. You can take the square root of 4, so we could use that. You want to look for the biggest perfect square that goes into that 32. So 4 goes into 32, and 4 is a perfect square, so we could use that one. But that means we would have to simplify it a little bit further. 16 goes into 32. How many times does 16 go into 32? 2 times, okay? So we can do the square root of 16 times the square root of 32. Sorry, 16 times the square root of 2 would give us the square root of 32. What's the square root of 16? 4. What's the square root of 2? It's messy, so we're going to keep it as a square root. So the square root of 32 simplifies to be 4 square roots of 2. Here, we have 3 square roots of 45. If you have a number in front, you're going to save that number for after we simplify our square root. That number has to play a part in us finding our answer. So here we break up 45, 2 factors of 45, the square root of 9 and the square root of 5. We can use those because we know the square root of 9. The square root of 9 is 3. The square root of 5 is messy, so we're going to leave square root of 5 there. 3 times 3 is 9. So our answer is going to be 9 square roots of 5. If you need to slow down the process, pause the video. Okay, I'm going to keep trucking. The next thing we're going to talk about is square roots with variables. When you're taking square roots of something squared, the square root is saying what times the exact same thing would give me that x squared. Well, x times x would give me that x squared. So the square root of x squared is x. Easy enough, okay? When we have square roots, it's easy to break stuff into squares to take the square root of something. When I take the square root of y cubed, I could do the square root of y squared times the square root of y. Y squared times y would give me that y cubed inside the square root. We know the square root of y squared is y. The square root of y we can't simplify any further, so that's going to stay a square root. So our answer is y square roots of y. Okay, and we're going to do x to the fifth. Let's break up x to the fifth. If you break it up in squares, you get x squared times, the square root of x squared times another square root of x squared. That's x to the fourth times another square root of x. X squared times x squared times x would give us x to the fifth. This simplifies to an x. This simplifies to an x. This does not simplify, so it stays in the square root. X times x is x squared, square roots of x. Whew. All right. We're going to try this one, but we're going to try it on the back because I'm going to write it out expanded, and then I'm going to show you a trick that will work for simplifying variables and square roots. So we're going to do the square root of x. You can do this on the back of your paper. The square root of x to the 9th y cubed. If we break x to the 9th apart, just like we did in the other ones, we have the square root of x squared times the square root of x squared times the square root of x squared. That would give me x to the 6th. Another x squared would give me x to the 8th. And then another x would give me x to the 9th. X squared times x squared times x squared times x squared times x is 9. Then we break apart this y cubed. So we got a y squared, and we have another y. So again, all these are still under the square root because we haven't simplified it. X squareds, the square root of x squareds, we all know those are x. So those all simplify to x. The square root of x does not simplify, so we leave it the square root of x. The square root of y squared simplifies to y. And the square root of y stays the square root of y. So from here, I have x times x times x times x, so that's an x to the 4th. And I also have a y. All of those variables ended up simplifying out of the square root, so those are going to be out in front of the square root. My square root of x and the square root of y are left inside the square root, so I have an xy left inside. Okay. Now, that's a lot of work for one problem, so my kids at this point are usually saying, is this real life somewhere? And this is what I'm going to tell you. This is the trick to square roots. Since you're taking the square root and squares are 2's, this is the trick. You look at the exponent on a variable. And how many times does 2 go into 9? Okay. Well, 9 divided by 2 is 4 with a remainder of 1. Yeah? 2 goes into 9 4 times, and then there's 1 left over. Okay? Since it goes in 4 times, we have an x to the 4th. Since we have a remainder of 1, we have an x remaining in our square root. And you look at the exponent on the y, which is a 3. Okay? How many times does 2 divide into 3? Well, 2 goes into 3 1 time with a remainder of 1. So we have a y that came out of the square root and a y that remained inside the square root. You catch that? Okay, let's try this one on our notes using the trick. Okay, look at the exponent. How many times does 2 go into 4? So 4 divided by 2 is 2 with a remainder of 0, right? So our x outside the square root is going to be x squared. Do we have anything left inside the square root? Nope, because we had a remainder of 0. Okay. How many times does 2 go into, divide evenly into 11? Well, it goes in 5 times with a remainder of 1. Since it goes in 5 times, we have a y to the 5th, and then 1 remaining y inside of our square root. We'll do some more practice problems on the next video, more square root practice. So if you need some more practice on this, try the more square root practice. The next thing we're going to talk about are square roots with numbers and variables. Okay. This is a way that just the format that I do it in so that it is consistent every time. When you're looking at a number and some variables inside the square root, I like to simplify my number first. So 12 I could simplify into 2 and 6, but I can't take the square root of either one, so that won't help me at all when I'm simplifying. Other factors of 12 are 4 times 3, so I'm going to break that up into 4 times 3. And then I'm going to take my remaining variables and I'm going to leave those x squared, y cubed, and 1 square root. From this point, I'm going to simplify the square roots that I can. I know that 4, the square root of 4, pause.